Good morning, all. Sorry, good evening, all. So we just wait for 2 minutes so that the rest of all members to join. Good morning, all. Sorry, good evening, all. So we just wait for 2 minutes so that the rest of all members to join. Good morning, all. Sorry, good evening, all. So we just wait for 2 minutes so that the rest of all members to join. Good morning, all. Sorry, good evening, all. So we just wait for 2 minutes so that the rest of all members to join. Okay. Good afternoon to all, and let us start our class now. So now we start with modern convolution neural networks onwards. So up to now, what you in the mid one, what you have, they are all somewhat related to machine learning. But at present, what you are focusing, at present, what you are going to learn, what you are focusing is entirely a new syllabus. You never studied, and all these are on the core of and the heart of the deep learning. Here, you studied with the deep convolution neural networks. The first and foremost network is AlexNet. The AlexNet is the first fundamental deep learning network which is introduced in 2002, and then we start reading about VZZ and learning about VZZ, and a network in network, that is called residual networks, we studied here, and GoogleNet, LeNet, batch normalization, residual networks, and densely networks. Again, I'm saying every method, every model, what we are going to learn is having very much in-depth and new topics. All are new topics to you. And these are all the only topics where the current research is going on. The current research on AML, what you are seeing, all the research is going on the modern convolution neural networks. And after that, in Unit 4, we start reading about recurrent neural networks and text processing, where NLP, the basic of NLP is somewhat needed for whenever you need to understand for Unit 4. And Unit 5 is completely an advanced topic of deep learning, where you have GANs and adversarial GANs. So without wasting much of our time, so let us start AlexNet. So before going to the AlexNet, I would like to ask you, the people, is how the convolution process is happening. Hope everyone is aware of it. What is the convolution? How the convolution will happen? I hope everyone is aware of it, because the purpose only I gave the top question in the mid exam. Hope everyone attempted that question also. Is it okay?
Yes,
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 sir.
sir.
Yeah. So before I'm discussing about AlexNet, do you know CVPR? CVPR? Anyone? Okay. Anyone of you here ImageNet? ImageNet. Have you heard the term called ImageNet? Yeah, very good, Vidyasagar sir. So what you given is correct. So let us share the screen. So this is the first fundamental paper which is released for AlexNet. This is the base paper for the AlexNet. This is the base paper for AlexNet. So where it is released? In NIPS. It is released in the proceedings of CVPR. What this problem is dealing is, this problem is dealing about ImageNet LSRC problem. So how many classes the AlexNet able to solve? 1,000 different classes. 1,000 different classes. So when it is released in 2012, the problem released in 2012. So this is the ImageNet where you can see. So you can download all the challenges which are there, which will be released in ImageNet. You can download all the data sets here. They are all completely free, and still the ImageNet large scale visualization recognition challenges are going on. If you are interested, you can participate here. What basically they are? So LSRC 2012, in LSRC 2012, this AlexNet is introduced. From there onwards, the deep learning started evolution. Because of the AlexNet only, because of the AlexNet only, the AI booming of AI started, and you know the impact of AI. This is all because of the introduction of AlexNet. So where we are discussing about the root cause of the booming of the AI. So what is this task? This task is doing classification. AlexNet is used for the classification, but along with the classification, it is also doing localization. For this problem, so how many classes here it contains? It contains 1,000 classes, 1,000 classes. If you download this, then you can see the ImageNet. What are the different samples images are there? Let me show you those things.
Skanda sir, your voice not audible, sir.
Oh, sorry. I thought it is, and I just said many things. So let us, sorry, let us tell you again. So in ImageNet, if you see here, the ImageNet, it contains thousand classes. These are all the classes. Let us see what are the classes are. So it is a English setters, Egyptian cat, Persian cat. So all kinds of regular items what we see in the real life, all the classes are there. This is the class ID and this is the class label. This is the class label. So like that, you have these many number of images. Each thousand class contains 250 samples. Each class contains 250 samples. What is the purpose of ImageNet classification? The purpose of ImageNet classification is about object recognition as well as the localization. What is the difference between a classification and localization? So in 2012, it is only started with in 2012 it is only started with classification. Nobody think about okay, AlexNet is also used for localization also. What is the advantage of the AlexNet is here the direct advantage is autonomous vehicles. Autonomous vehicles. So the autonomous vehicles requires to recognize all kinds of AI classes. And instead of that classification, we also need to have a localization. Localization means up to what extent that image is there in the observed area. We call it as IOU, intersection over union. Intersection over union. We call it as IOU. So the basic advantage of AlexNet is for object recognition and object classification. So in recognition concept, there involves two concepts. So first of all, in object recognition, first of all, you need to have what is that object and up to what extent that object is there. So object recognition and object in object recognition involves one step is a classification. Object recognition and detection. Is both are same? No. Recognition means classification. Detection means finding which class it is. So it is classification with segmentation. Classification with segmentation. So actually, if I say the segmentation with classification is the correct word. So first we do the segment that object. After segmenting that object, we do the classification. We do the classification. Means suppose let us take an image. So let us take this. Yeah. So this is actually ImageNet images. You see here, these are all the images. These are all the images. So all these images, what you are seeing here, all these images are you able to recognize it? No, because they are very tiny one. If you observe this part, what you say in the right side part, this red color and yellow color and green color, you are seeing these bounding boxes. These are called bounding boxes. So in the bounding boxes, The bounding box we can draw using localization only. Means this scooter is there. This scooter is there. This scooter is occupied only this part of portion. You observe my cursor, only this yellow color part of a portion. This is only recognized as a motorcycle. If you observe this, see this, the color represents the motorcycle. And this is represents the helmet. So the green one represents the helmet. And this one represents the car. And the right side is also represents the car. Which means the object, up to what extent it is there in the image. Means some portion will be there, some portion will not. If you observe this car, half of the portion is missing. Sorry, half of the portion is missing. Why? Because half of the portion is out of this image. If you observe the back side of the car, if you observe this back side of the vehicle, back side of the motorcycle, it is also 90% of the object is covered with other objects, and 10% of the object only you are visible. Which means up to what extent that object is also available in that image, that is called localization. So only 10% of the image object is also there in the image. Still then the our model has to recognize what kind of object it is. I hope you understand the computation complexity involved here. Means we are not only working with 100% images, we are working with the images which are occupied for 10% of the images also. 10% of the images also. The popular application of the AlexNet is a nebula classification. I hope everyone knows that nebula classification, which means the nebulas, the galaxies which are observing from the telescope. We are able to electron telescope. We are able to classify it. These classification purpose also we are using AlexNet, because you observe that what is the percentage of the images which are there when you observe using the telescope. Apart from is other application is deforestation. Deforestation means there involves two samples. One is, if you take the spectroscopic images, if I talk about a meteorology concept, the spectroscopic images, the deficiency of any metal on a spectroscopic images is very tiny one. But we need to detect it. So that is our motto. That is our objective. From this object onwards, this advanced deep learning means advanced AI started. I hope everyone understand what is the impact of the AlexNet. Now let us start the learning of the AlexNet. So if you see the screen, this is the AlexNet architecture. Every image we represented with three objects, three layers: red channel, green channel, and blue channel. Just a sec. Yeah, red channel, green channel, and blue channel. So these channels represents a corresponding image, corresponding channel for every image. These channels are passed to 11 by 11, 11 by 11 filter size with striding equal to 4, with striding value equal to 4. So what is output of that? Anyone can calculate it. So here the input image size is 227 by 227 and filter size is 11 and striding equal to 4. What would be the output? Here no padding is there. What is the formula? N minus f plus 2p by s plus.
+1.
So what is that value? 227 minus
11
11
divided by
divided by 4.
4 plus 1.
Yeah, 4 plus 1. So you will receive 55 by 55. 55 by 55. And just a second. How many filters we applied here? 96 number of filters we applied. 96 number of filters we applied. So this is called the output of this operation. We call it as feature map. We call it as a FM, feature map. Still then, this image is too high. That's why we applied for max pool technique with a filter size of 3. With a filter size of 3. So what would be the output for this? And shredding equal to 2. So what would be the output?
27.
27. So what
27.
is the formula for this?
Input size minus
Input size minus filter size divided by
filter size divided by S
minus stride by stride. Okay,
plus 1.
plus 1. In any formula, plus 1 is common. And again, here if you see, same. What it means same is, again we are applied 11 by 11. Again we applied 11 by 11 filter here. Again we apply 11 by 11, 5 by 5 filter here.
5 by 5.
5 by 5 filter here, and with stride equal to 4. With stride equal to 4. And again we applied max pool with 3 by 3 filter and stride equal to 2. Stride equal to 2. And again we apply 3 by 3, same convolution operation. And again also 3 by 3, again also 3 by 3. If stride is not given, which means it is 1. If stride is not given, which means 1. Here strides are not given. Strides are not given, which means stride equal to 1. So after receiving multiple convolution and max pool, convolution and max pool, convolution and max pool, convolution and max pool. So after end of the layer, then we convert this filter, this max pool, the feature map to a single dimensional array. To a single dimensional array. To a single dimensional array. How we convert the single dimensional array? Can you calculate this formula, this value? 6 into 6 into 256. What is the value? Anyone? 6 into 6 into 256. What is the value? Is my voice audible?
Into 16, sir.
Into 16. That's there in your screen. So which means I have a matrix like this, which is of 6 by 6. 1, 2, 3, 4, and 5, and 6. 6 rows and 6 columns. I have a matrix with 6 rows and 6 columns. Like that, how many are there? 256 matrices are there. Like that, how many are there? 256 matrices are there. What I done is, I just converted into one dimensional array. I just converted into one dimensional array. How to convert a one dimensional array? Suppose I have A, B, C, D, E, F. These are all 6 values, and I have 1, 2, 3, 4, 5, and 6. This is the second row. Let us think that up to this only. So how to convert is, I just till to A, B, I just transpose the first row, C, B, E, F, and I'll transpose the second row and append it to the first row. I'll transpose the second row and append it to the first row, which means it will continue like this: 1, 2, 3, 4, like that. A single line array will come. Like that, the size of this single array
All
is
right, let's move
1
ahead
cross
and try.
9216. 1 cross 9216. 1 cross 9216. 1 cross 9216. So this network we call it as FCN. This network we call it as FCN. FCN means fully connected network. FCN means fully connected network. Fully connected network. In fully connected network, why we need to convert this feature maps to a fully connected network? What is the need of conversion? Why we need to convert it? Can anyone tell me the answer?
To
After
reduce
now,
the spatial size.
sorry,
Reduce the size.
size is not reduced. It is 6 by 6 to 56. The same is same.
Okay. A blurrer shape like that.
No, that's what you are doing here. All these things you are
Classification.
doing here. What is the purpose of conversion of this feature maps to the fully connected network?
Classification, sir.
Yeah, good classification. But why we need to convert into fully connected network into single row? Especially in AlexNet, why they converted here? Can't we, without conversion, can't we go further? What is the need of conversion? Can't we, without conversion, can't we go for the classification? Listen carefully. Here it comes the major part of neural networks. This fully connected network, this is similarly like a multi MLP, your MLP. So multi-layer perceptron. It's similar like a multi-layer perceptron, where this is on every node. This is every node carries one single value. Every node, this is input node. This input node contains the single value, and this node contains the weights. This node again contains the weights, and this node contains the bias. And up to now, what you studied in the machine learning, all the backpropagation techniques will apply only here. This is actually where the classification is taking place, in this part, in this fully connected network only. But what is this? Up to now, this convolution process and max pooling operation. But what is this? What is this? Can anyone tell me? Up to now, we studied the neural networks where a neurons will be there, multi-layer perceptron is there, where each layer contains the neurons and a bias, and each layer is connected to all other layers, and we have a hidden layer like this. This is the hidden layer. We have a hidden layer. In the hidden layer, and this is the output layer. The hidden layer is there. In the hidden layer, we have all the connections, and we have a weights there, and we use all the weight learning algorithms like perceptron learning algorithm or gradient descendant algorithm, or all kind of algorithms will applicable only for fully connected networks. what is the purpose of this previous convolution and max pooling? What is the purpose of it? Can't we directly convert the image into one dimensional value, and can we go for the weights training process? Is my question everybody understood?
So overfitting, sir. So problem is there.
Up to now we didn't start a training. If the start training, then underfitting, overfitting, everything will comes. Already machine learning, and I would like to ask you one more question also. You just reminded me one important point, sir. Although you learn the machine learning and there the neural networks are there, then again we are studying CNN. What is the purpose of it? If the same task is doing by the CNN, the same task is doing by the neural networks, then why I need to have a two different techniques to increase my syllabus? Because this AlexNet needs to be a basic of the deep learning, so I need to go in depth in it. That's why I'm discussing all these concepts. What is why the CNN? Why we need to use the CNN instead of NN neural networks? Anyone? And what is this process? Convolution and max pool.
Scale down the images, sir.
Okay, scale down the images. If we scale down the images, what would be the benefit, and why we need to scale down it? Why we need to do it is scale down it?
For selecting the basic measure.
Data size can be reduced while maintaining the same vital information.
Very good, sir. Very good. I am not able to see the person's name. Who are saying the very good, sir. Previous Srihari sir, I hope so. Is also given the correct answer. But here, let me tell you the important concept. Everyone, please be attention this. The basic difference between machine learning and deep learning place is only because of the convolution and convolution operation. Why we are going for convolution and max pool operation? Why we are doing for a convolution process? Where comes the problem? Where comes the problem with the neural networks with the CNN? There will be two problems are involved in it. First problem is neural networks are suffers for high dimensional problems. Neural network is failed. High dimensional problems such as what you are seeing is a 227 by 227 image. If I convert this 227 by 227 into 3, if anyone multiply it, if I want to convert into one dimensional 1 by 227 into 227 by 3, let me see the value. 227 into 227 into 3, it's 1,54,587 nodes. For single image, I have a 1,54,000 nodes. So like that, I have a previously what we see the image net. In the image net, it contains how many classes are there? How many classes are there in image net? In AlexNet, what we are solving. How many classes are there?
1,000.
1,000 classes. Like that, thousand kind of different samples are there. Each class contains 250 images. Each class contains 250 images. Like that, 1,54,000 into 253 into 250 images. That is for one class. Like that, I have to do it for 1,000 classes, which means you can't match the numbers what it comes. That is the main problem with the neural networks. So neural network cannot handle the higher number images, which means high dimensional data sets. We call it as a high dimensional data sets. That is the first problem. The second problem is In machine learning, whenever we are dealing the machine learning, we should have a one, what you call a formula. We should have a formula, or if we are didn't using if we are not using the formula, we should have a strategy. Or if we didn't have a formula or a strategy, we should have a features. All these features are selected by either the person who involved for doing the research, or the persons who need to have the answers. Which means, suppose I am the person, I want to classify the persons into two categories. I want to classify the persons into two categories, class A and class B. Class A and class B. So I'm considering to consider the entire class into two classes, class A and class B. I'm considering, suppose the persons wears the gold ring in their hand. I consider that they are class A. If I didn't wear the gold ring, then I'll consider as class B. If I have that feature, what is the issue here? Now, after dividing class A and class B, for class A people, I make them sit into the front bench, and class B people, making them sit into the back benches. What is the issue here? Anyone tell me? What is the issue here?
Showing partiality.
Showing partiality is okay. Making the classes itself means showing a partiality. But what is the issue here? Suppose I am considering gold ring. Suppose if I consider gold chain, or suppose I consider whatever the some X component, they are all questionable constants. They are all questionable values. Suppose if I call the persons, suppose my number is Xavier, my name is Xavier. My name is Xavier. So my name starts with X. That is supposed. Now I'm calling the people from alphabetical order. I'm calling from alphabetical order. So when my name comes after 25th or 24th number or 24th numbers, which means by considering that every time I feel that my number coming every time 24th time. So if I ask the faculty, next time faculty will say that instead of A to Z, I will call Z to A. Z to A. Then the person starts with A will ask, sir, why you are starting Z to A? What kind of all these things are? Is they are biased one or not? Anyone?
It is biased, sir.
They are biased one. If I consider A also biased, if I consider Z also biased. That's why whenever machine learning techniques we are taking, all the machine learning techniques suffers with a biased constant. Biased one. Suppose I hope everyone is aware of this diabetic. Suppose in the diabetic, an H1B, HB1AC, if I consider that for India only 6 is the base value, below 6 is no diabetic, after 6 is the diabetic. Let us think about it. Then most of us are not fall into the diabetic range. Yes or no? Yes or no?
Yes, sir.
Yes.
Yes, sir.
If I reduce the value, so saying that my HB1AC value should be, if less than 4 is non-diabetic, greater than 4 is a diabetic. All the India, 90%, 99% India is a diabetic people. Means what I am considering, basing on that, if I do the population on it, then the inference, the outcome of the inference is changes. If the outcome of the inference changes basing on the method or basing on the feature I am selecting, then I am not giving a proper prediction. So to have a proper prediction, I need to have a automatic feature generation, automatic feature extraction. So this method, up to now, what you are seeing here, this method is called automatic feature extraction. Automatic feature extraction. So this automatic feature extraction will collect the necessary features, basing on the training parameters. That's why this automatic feature extraction will also call it as a black box. Black box stage in the deep learning. That's why this is the black box. That's why one more evolution comes, that is called XAI. That is called explainable AI. So in AlexNet, they don't know what feature it extracted using convolution and max pooling technique. Suppose I pass it a image of a cup. What feature it extracted using this, the AlexNet is unable to give the answer. Is unable to give the answer. That's why in 2019 onwards, one more origin of the AI started, that is called explainable AI, where how this feature is extracted and what kind of feature it is we are able to see this. So these techniques is started using one evolution that is called GradCam technique. GradCam technique. GradCam technique. So this GradCam technique is also not a new one. This GradCam technique is also a differential equation. Is also generated using the differential equation. So at present, this is not in your syllabus. That's why I'm not scratching your heads. But my major concern is in the AlexNet, you have a two parts. This is called feature extraction part. This is called feature extraction part. What kind of feature they are extracting? Feature extraction. And this part is the classification part. This part is the classification part. So what kind of feature that is extracting? Tell me please. What kind of features it is extracting? Okay, let me tell you. These features are called automatic features. Make it in your head, because from this point onwards, what we are going to discuss are basing on automatic feature extraction only. Automatic feature extraction only. Okay. So have you understood the basics of the AlexNet? Because if we didn't understand the basics of the AlexNet, then we can't go further. Now I would like to ask a question that everyone is seeing the screen, right? How many layers this AlexNet have?
3.
3 layers.
No. No. How many layers?
8.
Sorry.
8 layers.
8.
How come it comes 8? How come it comes 8?
Various counting various filters.
counting various filters.
5 convolution layers, 3
Okay,
fully
counting
connected layers.
filters. Okay, 1, 2, 3, 7, 8. What about this part? This part you are not considering. The answer 8 is correct, but the justification is wrong. That's why I'm asking.
Five convolution layers, 3
Hmm.
fully connected layers.
Very good, sir. I hope everyone seen the answer in the chat GPT or Gemini, but whatever it may be, the answer is correct. So there are total 5 convolution layers and 3 fully connected layers. So altogether it comes 5 plus 3, 8. So here it comes to the way why I discussing this concept is, suppose if I consider only the convolution layer, many of you ask for, sir, if I consider the convolution layer, then why we are not considering the max pool layer? Is max pool is not a layer? As max pool or pooling, min pool or average pooling is a subpart of the layer?
It is a technique.
Okay, convolution is also a technique then.
Minimizing the size, sir.
Minimizing the,
Size of the matrix. The input.
yeah, okay. But the answer is correct. Max pool we will not consider because it is a sub process of the, because every time convolution is followed by the pooling technique. This is called one bunch. This is called one bunch. I'm not making much more confusion. This is called one bunch. Up to where? Up to you went to RESTnet. Up to you went to RESTnet. From the RESTnet onwards, the concept is different. From the RESTnet onwards, the concept is different. From the RESTnet onwards, the concept is different. So AlexNet contains totally 8 layers, correct? Where in which 5 are convolution layers. So how many times the convolution is happening? 5 times. So it is a 5 convolution layers and 3 fully connected networks. Okay. So this is about AlexNet. So and AlexNet in 2012, the LeNet is started in 1990, and 2013 we have ZFNet. So obviously after the AlexNet, ZFNet is a name which is came from basing on the author or the person who invented it. This is Jailer and Fergus. Z means Jailer, F means Fergus network in 2013, which is also works for the same ImageNet SLRC 2012 issue. But here the major difference is the error rate is reduced when compared to the AlexNet. The ZFNet error rate is reduced. Then comes the Google LeNet in 2014, where the error rate is reduced to top 5%, top 5 error rate. And then VGGNet. The VGGNet is the next superhero in the deep learning. So VGG is actually a group. How Usman University is a group. So VGGNet is a one group. So visual geometrical group, that's name is VGG group. So it contains many kinds of layers. Many kinds of this group released many kinds of, just a second. This group released many kinds of networks. One is called VGG16, the popular one, and the other one is VGG19. The other one is VGG21. These are all the different networks they are released. But what is the issue of the VGG? The issue of the VGG is they are very in-depth networks. They are very in-depth networks. And from VGG onwards, there comes one more important concept that is called transfer learning. You nowhere see in your syllabus, transfer learning. You nowhere see transfer learning in your syllabus. But still there is a but here. But visual, this VGG blocks and densenet and ResNet all will be used the transfer learning concepts. All will be used the transfer learning concepts. Without transfer learning concept, these networks will not be useful. These networks will not be useful. So let us start the transfer learning now. So what is a transfer learning? Can anyone tell me what is a transfer learning means? Let us think about it. Let us think in this way. So if you know the cycle riding, you can learn bike very easily. What is it?
Sir, once again, sir, question.
Question is, if you know the cycle, you can apply the same knowledge for learning the bike.
Two-wheeler. Two-wheeler.
Two-wheeler, bike.
In both the
Apply our
cases,
skills, sir. Learn
In both the-
skills, sir.
Sorry.
in both the cases, balancing is matter.
Supervising.
Able to balance.
Okay.
Driving
So
is very
supervised learning. It's okay. Understood. It's a supervised learning. I understood it. But what is it?
Apply our skills, sir.
Very good. But you apply your skills, but you learn skills from where?
by skill.
You learn skills from where?
By skill, sir.
Previous.
Previously, you apply skills from the bicycle, and now you are applying the same skill from to where? To the bike, right?
Previous experience in the sense.
Means, yeah, that is called a previous experience, and we call it as a previous knowledge. So where in transfer learning, what we are discussing, what we will do is, let us share this link. In transfer learning, what we are doing is, so we learn some value. We learn some value. Let us say this is an X. We have some value. So I know how to classify. Cats versus dogs. I created a model. I created a AI model which is trained for classification of a cats and dogs. Classification of a cats and dogs. Cats and dogs. The same AI model. I am applying the same AI model I am using, and I am applying for classification of a cancer versus non-cancer cell. Cancer versus non-cancer cell. I am not changing the model. I am applying only the cancer versus non-cancer cell. But is it the transfer learning? No. What I will do is in the transfer learning, I kept some of the parts as freezed. Some of the models, some of the layers are freezed. Mostly all feature extraction process. In feature extraction process, what is the feature extraction process models? So let us see here. So these are all the feature extraction process in AlexNet. If you see the before concept of the fully connected networks, these are all called the feature extraction process. These feature extraction processes I will freeze because this model is already trained for ImageNet, which can classify the 1000 classes. So the image size reduction, the size reduction of the image is the same for all kinds of problems. So that's why I will freeze all this the feature extraction process. I will only train only this fully connected network. I will only train only the fully connected network. So we call it as a retrain. Instead of train, we call it as retrain. I will retrain the fully connected networks. I will retrain the fully connected networks. So, which means what process I am optimizing it? Anyone tell me what process I'm optimizing it? So by comparing both the layers side by side so that you can understand much more effectively. What model I'm optimizing it here?
Feature extraction.
Okay, feature extraction. If I freeze the feature extraction process, what is the benefit here? What is the benefit here? So I'm discussing about transfer learning. What comes to benefit here?
Correct prediction, sir.
No, we are able to reduce the time. Think about it. Think about the AlexNet, where where you have 1000 classes into 250 images. Altogether, you have a 2,50,000 all about 2,50,000 images. So you're doing all kind of image extraction or reduction techniques for 2,50,000 images. It will take a lot of amount of time. The same thing if you are applying for cancerous and non-cancerous, again the same process, right? This is the same old concept. So that's why in order to reduce the time, we use the transfer learning. The basic starting of the transfer learning will start from the VGGNet. These VGGNet, ResNet, and DenseNet. These are all the popular techniques of the transfer learning technique. Now this is about for today's class, because for transfer learning, if I start the transfer learning, it will take at least 2 hours of time, because if I start the VGGNet, like in VGGNet, because your syllabus contains VGGNet, which means you need to learn VGG 16, VGG 19, VGG 21, and VGG 11 also. So that's it for today's class. Any doubts? Any doubts?
No, sir.
Okay. Thank you, everyone, and good night.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.
Thank you, sir.
Thank you. Good night, sir.